Here we have a calorimetry problem. A 28.4 gram sample of aluminum is heated, placed in a calorimeter, and the temperature of the water increases. It's asking us to find the specific heat of the aluminum. So let's start by organizing our information. We have some aluminum, we have the water, and we're going to have a series of values for each of these things. We'll have M, C, T final, T initial, which from there we'll be able to calculate out the delta T. So now that we have a place to organize our information, let's start looking through the problem. We have a 28.4 gram sample, 28.4 gram sample of aluminum, heated to 39.4 degrees. There's our initial temperature, 39.4 degrees Celsius, placed in a calorimeter containing 50 grams of water. So there's our mass of the water, 50.0 grams. The temperature of the water increases from 21.00, so there's our initial temperature, to 23.00. There's our final temperature. What is the specific heat of the aluminum? So we're being asked to find C. Let's fill in the information we know. We know the specific heat of water is 4.184. We also know that the final temperature of the aluminum will match the final temperature of the water, so it's 23.00 degrees Celsius. Now that we have both initial and final temperatures, we can solve to find the delta T for both the aluminum and the water. 23 minus 21 gives us a change of 2.00 degrees Celsius, and then 23 minus 39.4 gives us a change of negative 16.4 degrees Celsius. So all we need to do is figure out the amount of heat that's taken in by the water, and we'll know that the amount of heat that is given off by the aluminum is that same magnitude, just opposite sign. So Q for the water equals mass 50 grams times C 4.184 joules per gram degree Celsius times my delta T value of 2.00 degrees Celsius. I can solve for that value of Q, and I get 418.4 joules. And I know that the Q of my metal is opposite that. So I can then set up my equation. My Q of the aluminum is negative 418.4 joules divided by my mass and my change in temperature. So divided by 28.4 times negative 16.4. When I solve this equation, I get 0.8983, and I should round to 3 significant figures in the end. So my final answer is 0.898, and the units on specific heat are joules per gram degree Celsius. So that is my value for specific heat of my sample of aluminum. And then we can box in our final answer, correct our sig figs, make sure it is correct, and then we are done.